Hello everyone, my name is Ida and today I'll be discussing dimensional analysis using chemistry units, converting grams to moles, moles to atoms, molecules, and all of that fun stuff. The first thing we need to understand is our conversion factors, and molar mass is one of them. Molar mass is what we find or we calculate from our periodic table, and the units for that is always going to be grams per mole. Another thing that I want to mention is that all three of these conversion factors are very helpful. And it's very simple to remember because all we have to know is that 1 mole is either 6.02 times 10 to the 23rd atoms, molecules, or formula units. It's the same thing. And this special number is called Avogadro's number. And it comes very useful in a lot of conversion factors, so I would definitely remember that. So here is the periodic table of elements, and what I really want everyone to understand is this bottom number here for each element. That bottom number is your molar mass. So for nitrogen, the molar mass is 14 grams per mole. Let's do another example, like calcium is 40 grams per mole. Fluorine is 19 grams per mole. Iron, 56 grams per mole. Cesium, 133 grams per mole. So every element has its designated grams per mole unit. So we need to just be very mindful of these units. Determining the molar mass of different compounds, we have sodium hydroxide to begin with. I really recommend everyone to have a periodic table next to them because we're going to refer to their appropriate molar masses for each element as discussed previously. So we have 1 sodium, 1 oxygen, and 1 hydrogen. So we're going to say 1 times the molar mass of sodium is 23, which is 23. 1 oxygen times the molar mass of oxygen, which is 16. And 1 hydrogen times the molar mass of hydrogen is 1. So that's just going to be 1. You're going to add these numbers up. 23 plus 16 plus 1 is 40 grams per mole. So the molar mass for sodium hydroxide is 40 grams per mole. Let's do another example that's a little bit more intricate. Ammonium sulfate, which is that. So let's account for how many of each element we have. That's always a good place to start. So we have, because there's 2 subscript, that means that 2 goes into the parentheses. So that's going to be 2 nitrogens. It's going to be 4 times 2, which is 8 hydrogens. And then we have 1 sulfur. And we have 4 oxygens, right? I'm just going to write OX so that you don't mistake it for a 0. So now for nitrogen, we have 2 times the molar mass for nitrogen is 14, and that gives you 28. The molar mass for hydrogen's 1. The molar mass for sulfur is 32. And the molar mass for oxygen is 16. So if I add all of these numbers up, I get a total of 132 grams per mole. So the molar mass for ammonium sulfate is 132 grams per mole. I just want to make a comment here. I am using whole numbers for my molar masses. Some periodic tables have up to 4 decimal places. You can round or you can use the exact numbers. It just depends on how precise you want your molar mass to be. Now I'm going to discuss how to convert from moles to grams and grams to moles. So for instance, the first question is saying, how many moles are in 15 grams of lithium? So what we have to always start with is what they give me, 15 grams of lithium. So I'm going to write that here. And I need to get to moles. But I know that lithium is so lithium is 6.9 grams per mole. I got that from the periodic table. So what I'm going to do is, if I want to get to moles, if I want moles by itself, I need to put grams on the bottom. Grams of lithium on the bottom, so that my grams cancel out. Okay, this is dimensional analysis. So I know that there is 6.9 grams of lithium in 1 mole of lithium. So now I'm left with moles, and that's what I wanted. So if I do 15 times 1 divided by 6.9, I end up getting, with the appropriate amount of sig figs, 2.2 moles of Li. And that would be your answer. Now, the second question is asking me, how many grams are in 238 moles of arsenic? So I need to first figure out the molar mass of arsenic. So from the periodic table, I know arsenic is 74.9 grams per mole. You're going to start with what they give you, which is 238 moles of arsenic. I want to get rid of moles, so I'm going to put it on the bottom. And I know that for every 1 mole, there is 74.9 grams of arsenic. So what happens here is the moles cancel out and I'm left with grams of arsenic, and that's what I wanted. So I stop and then I do my computing. 238 times 74.9 divided by 1, I get 178 grams of 178 hold on. I get 178.00 grams of arsenic with the correct amount of sig figs. So what I want to end off with is that if you're going from grams to mole, you're going to divide by the molar mass. And if you're going from moles to grams, you're going to multiply by the molar mass. So more practice. It says how many grams are in 2.3 times 10 to the negative 4 moles of calcium phosphate. So that's what calcium phosphate is. So we are going from moles, so let's write that down. We're going from moles to grams, right? So we're going to do 2.3 times 10 to the negative 4 moles of calcium phosphate to grams. So if I want to cancel out moles, I'm going to put moles on the bottom and grams on the top. Right? It's all about canceling out units. And always label. So my moles would cancel out. Now, we know that in every 1 mole of calcium phosphate, how many grams are there? So I need to figure out the molar mass of calcium phosphate. So let's do that. I have let's do calcium here. 3 times the molar mass of calcium, which is 40. Phosphorus would be, I have 2 phosphorus, so 2 times 31, which is 62. And then remember I have 2 times 4, which is 8 oxygens. 8 oxygens, 8 times 16, which is 128. Add all of this up, I got 310 grams per mole. So that means that number is going to go here. If I multiply the top and divide by the bottom, I end up getting 0.071 grams of calcium phosphate. On this slide, we're talking about something new, which is molecules. So just to jog your memory, we know that 1 mole of anything is always going to be Avogadro's number, 6.02 times 10 to the 23rd molecules. Okay, that's something that we will be using. So let's start off. We always start off with what they give you. 4 grams. 4 grams of, let's do this N2O5. So 4 grams of dinitrogen pentaoxide, N2O5. If I want to cancel out grams, I'm going to have to put grams on the bottom. And I want to put moles on top. So it's all about canceling out units, because now my grams will cancel out and I'm left with moles. So I need the molar mass of dinitrogen pentaoxide. So I'll do that real quick here. We have nitrogen, so that's 2 nitrogens times the molar mass of nitrogen, which is 14. 5 oxygens, so that's going to be, let me stay consistent here. You have oxygen, and we have 5 of them, so 5 times 16, which is 80. Add this up, I get 108 grams per mole of dinitrogen pentaoxide. So I'm going to put that number here. For every 1 mole, there's 108 grams of N2O5. I'm not done yet because I need to get to molecules. So I'm going to use this conversion factor. Because I want to cancel out moles, I'm going to put moles on the bottom. So my moles cancel out. And I know that in every 1 mole of something, you have Avogadro's number. Molecules. So that's where I stop because I'm happy I get molecules, and that's what I wanted. So I multiply the top, divide by the bottom. I end up getting an answer of 2.23 times 10 to the 22nd molecules of N2O5. Make sure you label. The last thing I want to discuss is determining the number of molecules and atoms. So they give us in this problem 3.26 grams of water, and they want me to figure out how many water molecules are there in 3.26 grams, how many hydrogen and oxygen atoms. So what we want to do first is figure out how many water molecules. So water molecules. So we start off with always the number that they give me, the information they give me is 3.26 grams of water. I need to convert to moles first and then to molecules, just like we did in the previous problem. So I know water is 18.02 grams for every 1 mole of water. Right? And then I continue. I know the grams of water cancel. I got 18.02 by finding the molar mass of water. I'm not going to do it again because at this point you should be okay calculating molar mass. If not, I would go back and practice that over and over again. I need to convert to molecules, so I need to put moles of water on the bottom and molecules on top. Whenever molecules come, I think of Avogadro's number. So 1 mole is 6.02 times 10 to the 23rd molecules. What happens is the moles of water cancel. I compute the following. I end up getting an answer of 1.09 times 10 to the 23rd molecules of water. Now I need to figure out how many H atoms, right? So what I do is I take the number of molecules I calculated, which is 1.09 times 10 to the 23rd molecules of water, and I use my ratio, meaning I'm going to use my subscripts. I have, for every 1 molecule of water, I have a total of 2 H atoms, hydrogen atoms, because water is 2 hydrogens for every 1 oxygen. So what happens is my molecules of water cancel and I'm left with H atoms, which is what I want. So I get an answer of multiplying the top, dividing by the bottom, I get 2.18 times 10 to the 23rd H atoms. Notice I'm always labeling. That's what we want to get a habit of doing. Then we want to do oxygen atoms. So we do the same thing. We're going to go to use how many molecules of water I have. So 1.0 times 10 to the 23rd molecules of water. And I know for every 1 molecule of water, I have, there's nothing here, so that's 1 oxygen. So 1 oxygen atom. I'm abbreviating oxygen as OX, so you don't mistake it for a 0. So what happens is my units cancel here, and if I calculate correctly, that's really just the number itself. Okay, and that's how you solve this problem. So this is your try on your own slide. I'd recommend you practice. The answers are provided, and remember that practice makes perfect.